Yeah, we're here. All right, so let's take a look at this together. This is a lesson that is very related to what you probably saw in Math 2. Okay, there's going to be some parts you definitely have seen in Math 2. So it's not all new. It's just applying what we did in the last lessons, multiplying our our multiplying our quantities together. Remember FOIL, remember distributing, all that stuff we were doing. Now we just have to do it including imaginary numbers. So there are two parts to every complex number. A complex number only has to do with the scenario including a real number, which are just our regular, it could be a decimal, doesn't have to be a whole number. The real number and the imaginary numbers denoted by this I. So this is 2 times I, 2 times the imaginary number. And the reason why I used to, when I taught this 3 years ago, I knew his name. I don't have it off the top of my head. But a mathematician was trying to deal with this scenario. They were like, what happens when you get a negative under the root? When you get a negative under the root, usually we're done. You can't have a negative under the root because what times what gives you -1? Not the same thing. -1 times -1 is 1. 1 times 1 is 1. So you can't take the square root of a negative number. So they decided that we were going to denote a negative √1 as equal to I. So it's equal to I. That's I to the first power, which is a little confusing and not necessary. There we go. All right, so we have real numbers, imaginary numbers, and this bad joke I'm about to tell is, in order to remember, you can't mix them. Okay? Because just imagine, when I was a little kid, I had imaginary friends. Sometimes, Every little kid probably has some little thing like that, little fantasy world. And if your imaginary friend, maybe in a dream, your imaginary friend tells you a joke, it's not good. Don't go and tell your real friends jokes from your imaginary friends, because they'll think, hey, that's weird. That's a little too, that's far, that's out there. Which maybe they'll like that, because I think people that are unique I like that. But if you get jokes from your imaginary friends, hey, don't go tell your real friends. They won't get it. And they'll think that it's too weird that you have imaginary friends still. All right, that's enough. I didn't even tell that bad joke well. I'm going to throw it in. You're going to get it again at the unit review, and I'm going to do it better. I'm going to have a disguise and props. You'll see. But the main thing is, real numbers can be combined with real numbers, imaginary with imaginary. So please combine these real and imaginary numbers. Go ahead and do that for this example and for this example. What are we going to get when we combine our real numbers and our imaginary numbers? And in this case, we're just doing adding and subtracting. And they function exactly like regular real numbers. As long as you keep them separate, combining them is the same. All right, so I look here and I see that 7 and 5 are real numbers. I can combine that. The real number goes out front, 12. The imaginary number follows, 2y, or 2I. All right, that's all we had to do. There's a few homework problems like that in your guys' set. So it was 1 through 16, but there was like 3 that are kind of just combining numbers. Okay. Here, look, we got 8. We got 3. Those are 2 real numbers. Positive 8 minus 3, 5. Negative I and positive 4. 4 minus 1i is 3i. So we end up with, combining those, 5 plus 3i. Here are our 2 answers. Everyone good with reducing and combining? That sound pretty like something we've done so far, pretty much? Okay. Yeah. All right. So I think that gauging that you've seen imaginary numbers before, it's really good. These 4 identities, I'm not going to talk too much about the I will. The I will is just helpful to know that I to the first, second, third, fourth. And then when you do I to the 5th power, you end up with the same answer as I to the first. I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, 10th, 11th, 12th. You keep getting these 4 answers. because you're just combining root -1 over and over and over. And it changes it positive, it changes it negative. You combine them. All these things happen that give us, no matter what, this, or this. These four answers are always going to be in play, okay? So let's look and see about this. 3i times 7i times 3i. Multiply your coefficients. 7 and 3 is 21. And then we're going to end up with I times I, which is I squared. Now this, when you have I squared, that's where you want to go up and look at the identity and just substitute, since I squared is -1, we substitute that here. So you're just using the I identities to substitute, if you can. Since I squared is equal to -1, I went ahead and just substituted it in here for my I squared. What do we get? -21. Okay. See if you can have the same success in doing this. Just remembering at the end, you'll combine like terms. Okay. So let's try that. Yeah, we're going to get out early here too. Maybe we'll do a few homework problems. Let's do it. I'm going to get that ready. So we'll do the first couple from the homework. That's not it. There it is. Yeah, we'll do a couple of these. All right. Tell me in the chat if you need me to just start this so you can kind of get an idea on it. Anybody in the chat need me to start it? Yep. Let's do it. 2i times 3. We're going to write that as 2i. And I'm just going to put it as times 3 for now. I'm just going to really put multiple steps here so that we can see, hopefully enough room. You can see the process. Okay. Then I have 2i times -5i. So I'm going to go positive 2i times a -5i. You see, it doesn't hurt. I mean, I can just make every little baby step and we could see it. It's fine. Okay. Now, the first one here, 2i times 3 is 6i. And then positive 2i times -5i is -10i squared. Oh, I know what this is. I squared, we already know what that is. So what I can do is I could bring this over here and I could rewrite it as 6i, one sec guys, minus 10 times the -1. Okay, because I know that this I squared is equal to -1 by my I identities. The I will tells us. So now go ahead and finish that out. Make sure you put the real number out front and then tell me in the chat what you get. What did you get for this example problem 3? Tell me in the chat. Yeah. You know, good. Isabel, you got it? And let's put the real number out in front first next time. Because just remember, real jokes are better than imaginary jokes. Real jokes have to come first. You can't start with the imaginary jokes. Mm-mm. See, I'm trying to integrate it back in. So yeah, same thing. You got to put those real jokes out front, the real numbers out front. Nah, no worries. Isabel gave me an opportunity to say my bad joke again, so thank you. Sadia, do you see the same thing? Let's put the 10 out in front. Good. Good, good, good. Good. Don't lead with those imaginary friend jokes. Mm-mm. I think that this entire joke is an imaginary joke. It's actually an imaginary joke, right? Huh? We don't want that? What could you be referring to? I see. You want to hear more imaginary jokes. Alicia, tell Victoria next time, like at dinner. Tell her, today we learned about imaginary friend jokes. I guarantee she'll know what you mean. She might think it's funny because in class this goes better. All right, let's see what we got. This is going to be 6i. Negative 10 times negative 1 is positive 10. We just have to put the real jokes out in front of the imaginary jokes. That's our answer. All right. All right, give it to me. Thumbs up, sideways, or down. Thumbs up. We've seen it before, really. It's just using the I identities, the I will, and using what we know about polynomials. Okay. Very good. Very good. Tell me in the chat if you want to see one more example, or we can do 1 or 2 homework problems. Let me know in the chat. If you want to see another one, you want to see a couple homework problems. I think that sounds probably pretty smart. Let's do that. You get some homework out of the way. All right, let's do that. You don't have to have your homework in order. So even though we're going to start on, we'll start on number 5. Just start with number 5. Just start with number 5. It won't make any difference. Okay. So I'm going to write what number 5 is. So get out a piece of paper. This is the homework for it. And for those watching at home on the video, you tuned in on the right day, because we're actually doing some example problems that are homework problems. Yeah, as you know, we have enough of these. Let's do a couple. All right. Whoops. All right. We have -1, -8i, -4, -i. I like to circle the ones that I can combine. Remember, always lead with your real jokes. So I might come in here and say, well, I know that these are for real. These are imaginary. Combine those. Same rules as combining positive and negatives. Same sign, just sum. Same sign, sum. Different signs, take the difference, subtract them. Another way to think of it is you're underwater 1 foot. You go down 4 more feet, you're underwater 5 feet. Did those. You're underwater -8 feet, 8i, but it's really -8 of these i's. -8i minus 1i, -8 minus 1. Underwater 8 feet, go down another foot, -9i. So however you have a logical way to combine positive negatives, think about it in different ways. You think about underwater, above water. You could think of it as my rules. Keep the sign of the large number. Same sign, sum. Different sign, difference. So add them if they're the same, subtract them if they're different. But you keep the larger sign no matter what. That one was like too easy. I need to find a better one. Should I do the hardest one? Yeah. Mm-hmm. We're going to do 15. That's how confident I am in you guys. I'm like, you don't need any underhand pitches. All right, knock it out. This is number 15. Remember PEMDAS. I'm going to tell you, these right here, you got to combine those first. Nothing to do in the parentheses. We can't do anything in the parentheses. But there's no exponent, so we got to multiply next. All right. I'm going to do these. 7i times 3i. First, I look at the numbers out in front. 7 times 3, 21. I times I squared. Okay, that's going to be something I deal with next. Because what is equal to that I squared? What is I squared equal to? Let's go ahead and pull back our identities. And it looks like we said before, if we were right, it looks like I squared is equal to -1. That makes sense. It makes sense because I is root -1. If you multiply root -1, think of it as root -1 squared because we're multiplying it 2 times on itself twice. So a root and a squared value is going to cancel each other out with this. Square root and a squared. So -1 for I squared. -1. So it's -21, -8 minus 6i. Now it's time to distribute. Go ahead and distribute that. Yeah, 21 times 8. That one's a hard one. But do 20 times 8. 20 times 8. And then add another 8 because there's 21 eighths. Hokey doke. Negative times a negative is a positive. 21 times 8. Well, 20 times 8 is 160. Because I think about that, 20 times 8, because 2 times 8 is 16. So 20 times 8 is 160. But it's 21 times 8, so it's 1 more 8. So we have 168. Negative times a negative for the second one. Negative times a negative is a positive. 21 times 6. Well, 20 times 6. 20 times 6 is 120. Add another 6. 126. If you're like, I'm never going to do that, I don't even want you to ever say that again. Don't ever do that. I might do it again, but you don't have to. All right. Feeling pretty good about this homework assignment for you guys. You guys, how do you feel? Thumbs up, sideways, down? Yeah? Yeah? Anyone else without picture on? Yep, I see him in the participant list. Go ahead and give me a thumbs up, sideways, down in the participant list. Something different. We never do that. Anyone else? Yeah? All right, thanks. I see a few thumbs ups. Very good. All right, thanks, Santana. Perfect. All right. And let's go ahead and stop the video then. I think that's all. Good luck at home if you're following along. Stop that.